feet and that much ID for a gas pipeline of that, what is the equivalent length in terms of 1 inch ID? You can tell whether it's more than that, more than 33,000 or less than 33,000. You can do that, right? I can ask this question because this is what I teach you, okay? What about the derivation? I get a question like this, okay? I think on that day I forget. The formula of equivalent diameter for isothermal case. I have dE over here, and I have dA and dB over there. But dB is the same as dE. So unknown, which is the equivalent diameter, is on the left side and on the right side. Is this a typo? This is not a typo because isothermal flow is depend on friction factor, and friction factor, if it's a rough pipe, is depend on that. So this is not a typo. Can we do it or we cannot do it? I think we can do it anyway by using the successive method. Okay? Because we have one equation, one unknown, you can solve it. It may be too much to add, put into the exam, but you're a senior student already. It should be fun. Can you do it? Probably. It doesn't matter, it can be put as a bonus point, right? 20 points. If you cannot do it, you can still get 100. It may not be there. Okay, look at Weber equation. Do you know how to derive this? Equivalent length thing. The derivation itself. It takes 3 lines, so maybe 3 minutes. Should do it. What about pipe in series? Pipe in series, I have 1 line, 2 line, 3 line, 4 line, 5 line, 6 line, 6 minutes. So you should be able to do. You should be able to derive the equation in the pink box within 6 minutes. Okay? Or double that time, 12 minutes. You should be able to do it, right?
What's the point?
Yeah, 10 times. What about we have parallel? You don't have 3 lines, 4, 5, 6, 7, okay, 7, 8 minutes. Double that time, maybe 19 minutes. Should be able to do the derivation too. Did you check that? The derivation of this equation is fair because the equation, like Panhandle and Weber, is given. If you don't know how to do it, it may not be there, so you may skip, take your risk, or you may just try it. Okay? It may not be there. I cannot put everything over there. Loop pipe, I loop A and B first, then connect with C. No problem, right? Let's talk about Mr. Bullard part, water injection. In here, I see just one calculation, which is that's that. I think there's some calculation over there for the pump, and it's have the ice. Yes, this one. Can you do this?
Yes.
So I change the number a little bit. Hey, partial pressure for frag pressure. Frag pressure is a little bit, maybe not 0.65, maybe 0.64. I change from 0.65 to 0.64. Can you still do it? But you cannot do it, it's not the same. Hydrostatic head, the density is not 1.06, it's 1.05. Can you still do it? Depth, injection well, depth may not be 5,000, maybe 4,900. You can still do it, right? Just put it in the calculator. So in this one, it's just one example. Maybe 10 points, okay? Easy 10 points if you want to do it. It may not be there, okay? But it could. And this is a recommendation for the project. Number 13, manifest law. Manifest law, I think it's kind of fun. So if I give you this chart, one chart. This chart. I tell you, angle is 15, fluid is water. I have water flow in 2-inch pipe. This is actually for the graph for 2-inch pipe. I have water flow in 2-inch pipe. And I have air, compressed air, flow in that 2-inch pipe. I tell you, mass flow rate of water at that location and mass flow rate of gas at that location. Can you tell me VSL, VSG and tell me what is the flow pattern? Like draw the line over there and tell me the flow pattern. Forest, Henderson. Anderson, right? Or Florent Anderson. Can you do it? So I give you mass flow rate. 1 kilogram per second for water, 20 kilogram per second, or maybe 5 kilogram per second for air. Can you tell what is the flow pattern based on this flow pattern map? So basically you have to calculate VSL, VSG. So you have to get volumetric flow rate first, right? Of course I have to tell you the density and other fluid property. Then you convert it, you do unit conversion, it's just a unit conversion. Once you get the flow rate, divided it by the pipe cross-section area in the same unit. So if your volumetric flow rate is cubic foot per second, the area has to be square foot. Okay? If you do everything, but this thing is in meter per second, so it may be better if you do in meter per second. Flow pattern can be determined by two methods. Use this chart or use the dimensionless chart. Dimensionless chart is very fun. So this is dimensionless chart. The only thing that you have to know is this page. Did you memorize it, Forrest? Okay. So transition A is F versus X, and you check transition A first. Transition A, and you do F versus H altitude. If it's not below this, is not stratified flow. Then you check if H altitude less than 0.35 or not. So if it's not over there, it's not another flow. But if your F versus H altitude, let's say it's over there in this burst bubble flow zone, it doesn't mean that it's this burst bubble, because transition A can check just if it is stratified or not stratified. It cannot tell that it's this burst bubble flow. To check this bubble flow, you have to check transition D, which is the plot between T and H altitude. If you do T and H altitude and it's over there, or maybe over here, then it's intermittent flow, not this bubble flow. Forrest, are you good? Okay. This chart is only for 0 degree, and this is a general chart for annular flow. Can use for anything. X and Y. If I calculate X and Y for you, you should be able to read the chart. If the engineer cannot read the chart, you should stay here with me. Okay. Just reading the chart. What about the pressure drop? Pressure drop requires you to read another chart, another kind of chart. So if I calculate all this for you, calculate everything, tell you everything in order, FC, blah, 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 blah. The equation is also given, so I calculate all this for you. And then, so what you have to do is just use a chart, xm0 and ym. Then you read h altitude. From h altitude, you read this phi c squared. So go from there, phi c squared, then you get the value of phi c squared. Then you plug it back into this equation. This equation is given, right? Is it? Yes. So you know that term, you know phi c squared, you can do the math and get pressure drop per unit length in the core. Just read the chart. If you cannot do it, you stay with me. Okay? If you can do it, okay, I'll let you go. Flow pattern is very specific to angle, okay, viscosity or something, fluid property. Okay, question. Scott Curtis. Where do I incorporate the impact of pressure and temperature in flow pattern calculation? If you look at the parameter or this parameter, I don't have pressure temperature, you see. F, K, T, there's no pressure temperature. So this method that uses a chart, does it incorporate the pressure temperature already or not? It is. It incorporates the impact of pressure and temperature through the fluid property. Okay? Look at definition of X. It has viscosity, right? Density, viscosity. So that is depend on pressure and temperature, right? It has actual volumetric flow rate divided by the area. So VSL is the actual flow rate divided by area. Actual flow rate means you have to take it into account of phase change already. So if you know the flow rate at the standard condition, 10 barrel. Okay, in there it may be 10.1 barrel because gas doesn't come out from the solution yet. Okay, and the viscosity may be a little bit less because there's gas inside. So this means this equation incorporates the impact of pressure and temperature through the fluid property. Okay, if I have not said that, now you know that, and if it is in the exam, I hope you can tell the right answer. Use of the chart. Okay. H altitude x, you go and read the value. Of course, dashed line, solid line depend on whether it's laminar flow or turbulent flow. Okay. How do I know that it's laminar or turbulent? So I have to know this part. D VSG rho g over mu g. I may give you that value. Okay. I give you y value and I also calculate that for you, and that equal to maybe 10,000 or something. So I give you D Vs. Okay. The top part. D VSL rho L over mu L. So that is Reynolds number based on superficial velocity. It's not really accurate, but it's good enough to tell if it is laminar flow or turbulent flow. Because the actual Reynolds number will be somewhat higher. Because actual V will be more than VSL, right? VSL is lower than actual V. You know that? VL is greater than VSL because VSL is flow rate divided by the whole cross-section area. But VL, actual liquid velocity, is the same flow rate divided by maybe just half of the cross-section area. So actual velocity is more than the superficial velocity. And if I have VSL divided by whole up, I get VL. Do I not? Let's go back. It's here. VL equal to VSL equal to divided by HL. This equation is not given, and I tell you now that you may skip or you may memorize it now. It may not be in the exam, but if you don't want to take a risk, you should know that. It's not that difficult. Okay? It's going to be a lot when we add everything together. So average of fluid property is based on the whole one. For the case of oil, gas, or liquid and gas, viscosity is weighted average based on the whole one. But for water, oil, water, you use that equation. You don't need to memorize that equation. It is given in the exam inside, or it will be given, or it may be given. If you need it, you will have it. Okay. If you need it, you will have it. Don't worry about it. But you need to know what is HD. I just give you this, but I didn't tell any of that you did. Okay. So you need to know HD is a dispersed phase whole arm or something. What else? Gas plant is no calculation. Don't expect any calculation from gas plant. Good? Not good? This exam is easier than the last year exam because last year is -2. This time is just -1. So I have intention for you to graduate. Let me show you something before we do casting. What is in the syllabus? What did I put in the syllabus? Any question so far? No? Let's take a look at syllabus real quick for this exam. Okay. Steven? If you cheat in this exam, what do you get? F. Okay, the grade of F is given. In addition to the sanction from the university, whatever sanction from the university, maybe they just give you reprimand or something, or say, hey, you have to do just reprimand In addition to that, the student who cheat in this class will get a grade of F. So don't cheat. Cheat in class, what is cheat in class? Steven, did you cheat in this class? No? Okay. So what is cheating in this class? Cheat exam, or copy what? Homework is counted? So copy the quiz is cheat in this exam. Cheat in this class, not in the exam. What about copy homework? What do you say? Copy homework will get what? Okay. Daniel, copy homework will get? And did you copy each other? No? Okay, you're fine. So, in addition to the sanction from the university, student who cheat in this class and will get that. So, just you don't have time to cheat in the exam. Let me tell you. Just do your stuff, and the person next to you does not need to do it right. Okay? If you want to copy someone, you should copy me, but I don't do it for that. I don't do anything like that. So don't try to copy from someone who may not know either. And in the exam, when you see long equation or long question, just read it. Okay, it will be fine. Just read it and try to do it. Okay, most of the time, if it's too difficult, it's just required to know like basic calculus. Can you do integration of polynomial equation? X to the power of 2 integrated is x to the power of 3 divided by 3 plus a constant or something. You know how to do that? Yes, not a problem. That can be on the test. Those 7 questions can be done. Let's do something about heat transfer. Question about exam. Do you still have questions? More questions for me about the exam. Okay. This time, first name starting with A will be over there. A, B, C, D, like this. And then E, F, something. I will do this thing. Okay. So if your first name is close to X, Y, Z, you may be in the front. Good. Try to come at 5. We will start 5 today. Okay. Question? No question at all. Yes? Yes.
On the Leyland equation, we'd have to calculate flow rate, standard condition.
When with the equation, you have to calculate flow rate as standard condition.
And you would give us the mass flow rate, the gas composition. How do we use mass flow rate?
So mass flow rate divided by density give you what? Volumetric flow rate, right? At the standard condition or at that point. If the mass flow rate is the mass flow rate at the standard condition, you get volume flow rate at standard condition. If the mass flow rate is the mass flow rate at that point, and they give you fluid composition at that point, then you get density. You can get density at that point. Can you? Can you get density at that point? Really? How do you do that? If I tell you the composition at most, you can divide it by 28.97 something and get the gamma, right? And you multiply by molecular weight of air something, you get the average molecular weight. After you have the average molecular weight, then how do you convert from mass flow rate to density? PV equal to CNRT, you use that, so you have to know pressure and temperature, and it has to be in absolute units, right? And PV, you don't know V, but equal to N. N is mass over molecular weight, and you move V to the next part, you get M over V, which is rho. So you can get the density at that point. Did you follow any of that? P V equal to Z. N is mass divided by molecular weight. R and T. So move V over there. M over V become rho. Okay, and you do some math. You can calculate density at that point. Mass flow rate divided by density at that point will give you volumetric flow rate at that point. It may not be in the exam, don't worry about it too much, but if it is, it can be 20, 30 points, okay? If it is. Alright, temperature estimation. How many quizzes left? Can I have the extra quiz? Tolani? You have to? Can I have one quiz? Okay. Let's go over the quiz first. Did you write your name and number? Make sure you do that. Okay. Write formula for Nusselt number. HD over K. That is the formula for Nusselt number. HD over K. Where does that come from? It's definition. Okay. It's like rho VD rho mu. Okay. HD over K is the formula for Nusselt number. Did you write it down? Please write it down. So next one is the formula for overall heat transfer coefficient, where the inner radius is the reference of the is the reference radius. What am I talking about? Overall heat transfer coefficient? I'm talking about U value. That's my U value. That R1 is the inner radius. Okay. So formula, write that thing down in it. It looks very silly, right? But believe me, when you write it, this means it go through your brain at least one pass. Okay. So that is overall convective heat transfer coefficient based on R1 or inner radius or inner diameter is the same. Okay. If you use D1, you have to change that to D1 and you have to multiply 2 on the top, multiply 2 on the top, multiply 2 on the top, and that becomes D. If you want to put D, put 2 on the top. Okay. So typically it's radius. What is this about? U value. Have you ever seen it before? Yes, it is in heater-treater calculation, right? Line heater calculation, it is there too. But this time we are going to use it for the temperature drop in subsea pipeline. Temperature drop for the buried pipe. It's just that. You finished writing that? No? Keep writing it. Okay, keep writing it. 1 over UR1 equal to 1 over HIR1 plus blah 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 blah. Write it down correctly. If the grader will just look at it and can tell if it's correct or not. If you did it wrong, you get 0 for that question. Very easy grading. No partial credit or anything. Okay, let's take a look at the physical meaning of this a little bit. Okay, U value is how good heat transfer in overall. Okay, let's say H1 or HI is a heat transfer in the inner pipe. Heat transfer in the inner pipe. HO is a heat transfer of the outer pipe. I have the subsea pipeline. Inside there's the oil, outside there's the water. Water is outside. If water flow very fast, move very fast, it have a lot of heat transfer, HO go to infinity. Is that going to make this equation diverge or like broken? No, it's still fine. So if HO go to infinity, this term just gone. Okay, but it doesn't mean that U value go to infinity. No, it's not that. So let's say I use a copper pipe. Thermal conductivity of copper is about 400 watt per meter per Kelvin. 400 watt per meter per Kelvin. This is in question 5. Okay, question 5. Last question. Copper pipe thermal conductivity is about 400. For carbon steel is about 50. Okay. Polyurethane, I think it's low. And what do you use? Google. But you have to tell you this. You can do it, right? Polyurethane. Okay, polyurethane thermal conductivity. And you open a reliable website, and it will be about polyurethane foam 0.03. 0.03, what is the unit? Watt per meter per Kelvin. Okay, 0.03. A lot less. Did you write 0.03 down? Write the unit too. Write the unit too. What about water? Water, it depends on what temperature. Okay, but you can use 0.6 for water. Water thermal conductivity. What about oil thermal conductivity? You can write 0.13. Let me search it. Oil. Engine oil 0.15. Crude oil about 0.13. Okay, 0.13, 0.14 is a good number for crude oil. Okay, that's crude oil. What else do you have? Carbon steel is 50. Oil is 0.15, 0.14, 0.13. All that is okay. Water is 0.6. Polyurethane 0.03. Copper pipe is 400. So I use copper pipe, okay, for this purpose. It doesn't prevent any heat to going out. Write the formula for Prandtl number. I hope you memorize it too when you write it. Prandtl number is mu Cp over K. Mu Cp over K. Do you write that down? It is over here. Mu Cp over K. That's formula for Prandtl number. And equation to calculate temperature at any location. Equation to calculate temperature at any location. This equation. Can you write it down? Okay. So that's it, right? So basically, you have the equation. Okay. And the equation has a bunch of parameters that you have to know. But you just substitute value in, and then you can get it. Okay. T at any z minus t at infinity divided by t inlet minus t infinity equal to e to the power of minus u pi capital D z over m dot and c prehand. M dot is a mass flow rate, kilogram per second. Capital D is inner diameter. Z is the length from the inlet in meter. So you write all those down. And okay, let me ask you something. Daniel, what is the formula for Prandtl number without looking anywhere? Can you tell me that? It helps, right? When you write it, it helps for you to memorize, right? So I think it's a good quiz, right? This is a good quiz. Okay. It's time's up. Thank you for coming, and don't go anywhere yet. Come to the front, submit quiz and homework. Okay, come to the front. Where you going, Taylor Cooper?
Good.